Wow, more equations. Anyway, but the first one is the same. This one is the same, so don't worry. You already know everything about it. This is the function, the equation that describes the whole range of salinity distributions. Okay? The only input parameter is f. F is the only parameter that determines this function. So now we do a little bit more. It's just mathematical manipulation. What do I mean by that is you have an equation, you have two sides, left side and the right-hand side, and you do something with both sides. For example, you do the natural logarithm on both sides, and you multiply with -1 on both sides. You get this equation. And you might ask yourself, why is he doing that? Okay. Why is he doing that? We do something more. We rename the left-hand side, we rename and call this y with a tilde symbol here on top. We just rename what's on the left-hand side and write it down as y. And the L over x, we call it a new x, also with a little symbol on top. Look at that equation. Look at this one here at the bottom. Okay. Let's get the pointer on. Let's have a look at this. Well, you've come across equations like this. That's an easy one, isn't it? It's a linear equation. You remember? Okay. The y here is somehow related to the salinity ratio, and the x here is somehow related to the normalized distance. It's an equation that has f and an f here. And you probably already know the answer now, because this is the brilliant bit of it. Okay, and we go to the next slide. It's a linear equation, okay, where f is the slope and f is the negative intercept, or minus f is the intercept, shown in this sketch. So if you measure your salinity distribution along your positive estuary, and you are plotted in a way where the x-axis is L over x, the inverse of the normalized distance, and the y-axis is the negative natural logarithm of the salinity ratio, you get a line. And the f value is what you can determine from the slope, and minus f from the intercept. So you actually have two indicators of your f value, and it's a quality control. You can actually compare whether the slope has the same magnitude as the intercept. Okay? All right, that's exciting, isn't it? So, okay. So that's already a key part of it. That's the idea. You can look at the salinity distributions from different years and have a look how the f changes from one year to the next. That is the task or the question of your exercise.